So since we have learned about a bunch of metrics in the previous video that we care about when we're designing, like all these metrics or all these timings that we learned about as far as CPU scheduling is concerned, let's actually look at some CPU scheduling algorithms, right? We'll just refer to them as scheduling algorithms for short. Okay. The very first one and the simplest one is called the first come first serve. Again, in this video and in the next few videos, we'll learn a bunch of scheduling algorithms. Each of these algorithms have their own advantages and disadvantages that we'll go over as we cover more topics, right? So what does, again, in this, I'll show you tons of examples so that you understand these concepts better, right? So here we'll make some simplifying assumptions, right? So we will assume, just for simplicity in this case, we will assume, as far as this example is concerned, I'll explain first come first serve through an example, okay? So here we'll assume that there is no input output. Okay, that's one assumption. We'll also assume that, remember, there is some time that is taken by context switching. Look at this. Whenever I have my dispatcher performs context switching, right? Context switching also takes some time, because during the process of context switching, the dispatcher has to remove a process from the CPU and now assign a new process to the CPU. But we'll assume, just for simplicity, that the context switching time is negligible, right? So context switching time is negligible, right? Or zero, negligible. Okay. So with these assumptions, the mathematics becomes simpler. Okay. Again, these are simplifying assumptions. Later on in this video, we'll see cases on what happens if you have IO also. Okay. This is just to give you the first cut idea of how these scheduling algorithms work. Okay. So now let's go step by step. Imagine I have these processes 1, 2, 3, 4, 5, 6. Each of these processes has an arrival time. What is AT? AT is nothing but the arrival time at which they arrive in your ready queue. Then each of them have a batch time. Batch time is the amount of CPU time they require to complete the process, right? So if you think about it, this is your AI, this is your XI, this is your PI itself. This is your process ID. Now, given this, how does the first come first serve work? The first come first serve, as the name suggests, whichever is the first process that comes into the ready queue, that will be served first. Very simple logic. Okay. Here, what is CT? CT is completion time, turnaround time, and wait time. Here there is a new thing called as scheduling time. Okay. ST stands for scheduling time. This is something that we have not discussed in the previous video, but scheduling time is the time at which a process is scheduled the first time. It is a time at which a process is scheduled the first time. The process is scheduled the first time. When I say schedule, it means it is given the control of the CPU the first time, right? Scheduled the first time. Okay. So that's what schedule time or scheduling time is. Now look at this. At time 0, what happens? Okay. Look at it. Very important, right? At time 0, what happens now? At time 0. So we are at, let's say, time 0. Okay. So let's draw a very simple diagram here. So let's assume this is my time axis, right? Let's assume this is my time axis, very simply. Now in this time axis, let's assume I am at time 0. Now what happens? At time 0, in my ready queue, which all processes are there? Only P1 is there. Because its arrival time is 0. At time 0, I only have process 1, P1, right? So since there is only one process, right, your first come first serve scheduler, your FCFS scheduler, will simply schedule that on the CPU. So P1 will start running. Now here your FCFS is a non-preemptive scheduler, which means once a process starts executing, the operating system does not preempt it. It let it continue till the time the whole process is complete. Okay. And the decision, so it's a non-preemptive. So FCFS is a non-preemptive scheduling algorithm. And what is the criteria with which it is scheduling? Based on the arrival times. Arrival times is the criteria. Arrival times is the scheduling criteria. Whichever has the lowest arrival time, that will be scheduled first. Okay, so now my P1 is scheduled. Look at this. This is my time, right? My P1 is scheduled. P1 requires, so what is the schedule time of P1? P1 is scheduled at time 0. Right? P1's burst time is 4, which means it requires, let's say, 4 units of time to complete. So what will be completion time? Its completion time will also be 4. Right? Its completion time will be 4. What is turnaround time? Let's write the formula for turnaround time. Turnaround time is completion time minus arrival time. Right? So what is turnaround time here? 4 minus 0, which is 4. What is its wait time? How much time did it wait in the whole thing? Now you can also write the formula for wait time as follows. What is wait time? Wait time is turnaround time minus batch time. Right? Turnaround time minus batch time. This is equal to 0. Very simple. Right? Very simple. See, we filled all these other details corresponding to this process. Because this process didn't even wait. It arrived. As soon as it arrived into the ready queue, there was no other process competing for the CPU. It was the only process. So it was scheduled. And at 4 units of time. So this now is 4. Between 0 to 4 units of time, the CPU was completely occupied by P1 itself. Okay. Now P1 is completed. Now what happens? Look at this. When P1 is completed, what is my time now? My time equals to 4. Which means in my ready queue, what all processes are there? This process arrived. So this process is now done. This process, I'll tick all the processes that are in the queue now. This process arrived at P2, arrived at 1 unit of time. P3 arrived at 2 units of time. P4 arrived at 3 units of time. P5 also arrived at the 4th unit of time. Which means my queue now consists of P2, P3, P4, P5. Right? My queue, my ready queue now consists of all of them. Because by the time I spent 4 units of time or 4 seconds, let's just call my units of time as seconds just for simplicity. By the time I reach 4 seconds, right, I already have P2, P3, P4, P5 in my ready queue. Now, which of these 4 processes would my FCFS algorithm pick? It says whichever came first into the queue, I'll pick it. So which one came first? P2 came first because its arrival time is 1. So the criteria to pick when you have multiple processes in the ready queue is the arrival time. Very simply put, right? So now what happens? Okay. So my P2 will now be scheduled. Okay. My P2 will be scheduled. Okay. Now by P2, at what time is P2 scheduled? P2 is scheduled at time 4. Right? My P2, what is the schedule time of P2? P2 is scheduled at 4 units of time. Now, what is the batch time? So 4. So what will be the completion time? Completion time is I started at 4 seconds. I have 5 seconds that I have to run. So I'll complete at 9 seconds. What is the total turnaround time? Turnaround time is completion time minus arrival time. The turnaround time is 8. What is the wait time? Look at this. What is the wait time? Turnaround time minus batch time. So my turnaround time is 8 seconds, but I only used 5 seconds on the CPU, which means I waited for 3 seconds in total. Very simple. Now let's look at it from this perspective. Okay. So this chart is called as a Gantt chart. Okay. This is a very, very useful way to visualize what's happening. Again, this table is one way to visualize it, but often in reality, people prefer Gantt charts because it's very visual to see what is happening after what. Okay. Reading the data from here is much more cumbersome. Reading the data from this visualized time-based chart. Okay. Again, this axis is time now. Okay. Okay. Now let's look at what's happening now. Okay. P2. At what time did P2 complete? P2 completed at 9 seconds. Right? P2 completed at 9 seconds. Right? Very good. Now, by the time my time is 9 seconds, my process 6 also came to the queue. My process 2 is now completed. My process 2 is not in the queue anymore. Right? It is completed now. Right? So now which all processes are there? 3, 4, 5, 6 are in the queue. Amongst these, which one will my first come first serve pick? My FCFS algorithm picks whichever came earliest or based on the arrival time. Which has the lowest arrival time? 2. This is the lowest arrival time. This corresponds to process 3. So now I'll schedule process 3. So at what time was process 3 scheduled? Process 3 was scheduled at 9 seconds. And it has a burst time of 6 seconds, which means it will complete at 15 seconds. Right? Very simple, right? So it completes at 15 seconds now. Right? What is the turnaround time? It is the completion time minus arrival time. So the turnaround time is 13. What is the wait time? Wait time is turnaround time minus batch time. 13 minus 6, this is 7. Very simple, right? So now this process is also complete. No more processes came in. So my queue only consists of 4, 5 and 6. Process ID 4, 5, 6. Okay, now amongst these 3, which one should I schedule? FCFS always says pick the one with the smallest arrival time. Okay, the criteria here is the smallest arrival time. Right? That's the criteria. Right? So Arrival time is the criteria, right? So now I have 3 here. It has the lowest arrival time. So I'll schedule this. What is this? P4. So let's schedule P4 here. Very simple. Okay. Now at what time was P4 scheduled? P4 was scheduled at 15. How much time does it require on the CPU? It requires 8 seconds. So when does it complete? At 23 seconds. 8 plus 15, 23 seconds it completes. What is the turnaround time? Completion time minus arrival time. Right? Very simple. Right? So what is the turnaround time now? 23 is when it completed. Okay. So 23 minus arrival time is 3. So 20 is its turnaround time. What is its wait time? Wait time is turnaround time minus BT or batch time. So its wait time is 12. Very simple here, right? Okay, this is cool. Now this is also completed. So at what time does P4 get completed? P4 gets completed at 23 seconds, right? So P4 gets completed at 23 seconds now. Now let's see what happens next. Now in my queue, I have only P5 and P6. P5 obviously will be picked because it has a smaller arrival time. So I start my P5 now. Okay. Now P5, at what time did P5 start? P5 started at 23 seconds. What is its burst time? 2, which means it will end at 25. What is its turnaround time? Its completion time is 25. Its arrival time was 4. So which means its turnaround time is 21. What is its wait time? Its wait time is turnaround time minus burst time. So its wait time is 19 seconds. Right? Very importantly, its wait time is 19 seconds. Okay. So, which means when does it complete? Its completion time is 25. Okay. So, no preemption. When a process is running, no other process will interfere. Okay. The operating system does not interfere and try to remove the process. We will also look at scheduling algorithms that enable preemption. Okay. This is the simplest of all. This is one of the simplest algorithms. Okay. So, now my queue only has process 6. Now, when does process 6 start? Process 6 starts at 25 seconds, which means its scheduling time is 25 seconds. When does it complete? Its burst time is 4, so it completes at 29 seconds. What is its turnaround time? Its turnaround time is completion time minus arrival time. So its turnaround time is 24 seconds. What is its wait time? Its wait time is 24 seconds minus 4. It waited for 20 seconds in total. Right? So this is this is one way to understand what process, when did it start, when did it end. But the 3 things that you need here is these 3 columns. You need the process ID, you need the arrival time and the burst time. Rest everything you can fill. And this visualization, this is your P6. When did P6 end? P6 completed at 29 seconds. So this way of visualizing is called the Gantt chart way of visualizing your scheduling algorithms. Okay. So this basically says between this time to this time, P1 had control over the CPU. Between this time to this time, P2 had control over the CPU. Between this time to this time, P3 had control, and so on and so forth. Right? This is a very simple example of FCFS. Again, going forward, instead of filling all these details, we will use Gantt chart to better understand how things are happening. Okay, this is much better way of visualizing this data. Okay, so all that is cool. All that is cool now. So again, I just wanted to cover the Gantt chart here. So we have seen the Gantt chart. Gantt chart is a chart like this, right? Again, we don't have to cover it because we have already drawn the Gantt chart for this. This is a Gantt chart for some other process, but Gantt chart is typically looks like this. This is your time axis, and each box corresponds to one duration of time in which a specific process owns the CPU or has control over the CPU or is assigned to the CPU. Very simple. This is a very, very popular way of visualizing scheduling algorithms. Now let's look at one more example, right? Slightly different example. Let's see how the whole thing works. Again, this is my Gantt chart. Here I am also filling all the rest of the details. I'm given, what are the 3 things that I'm given? I'm giving process ID, I'm giving arrival time, I'm given batch time. Okay. Again, here also we will use FCFS. First come first serve, which means, what does first come first serve basically mean? There is no preemption, and the criteria to select a process is basically take all the processes that are there in your ready queue, pick the one with the smallest arrival time or the lowest arrival time or whichever came first. Okay, now my question here is, so given these processes, I want to compute the schedule length. So the question here is, what is the schedule length? Imagine somebody gives you this data and asks you to compute the schedule length. Now let's start computing it. It's actually fairly simple. So Gantt chart is something which is extremely useful. Okay. So I'm at timestamp 0. Now at timestamp 0, is there any process here? No, none of all the processes have arrival time 8, 5, 7, 2, 4, 6, 3. Which means, what is the smallest arrival time here? The smallest arrival time is this. Which means from 0 to 2 seconds, there is nothing in the CPU. The CPU is empty. The CPU is literally idle here. Okay, very important. The CPU is literally idle between 0 to 2 seconds. Again, in your Gantt chart, this is my time axis. Now at 2 seconds, P4 came into existence. Right, at 2 seconds, P4 was added to my ready queue. Since there is only one process now, I can just simply add it. Right, I'll simply add P4. So when was my P4 scheduled? My P4 was scheduled at 2 seconds. Right, and when did it complete? Because its burst time is 1. Look at this, because its burst time is 1. My P4 completed at 3 seconds. What is the total, what is the turnaround time here? Turnaround time is completion time minus arrival time, which is 1. What is the wait time now? Wait time is nothing but turnaround time minus burst time, which is equal to 0. Right? Again, these formulas are very commonsensical. We have also discussed these formulas in the previous video, right? These are very, very common sense formulas. Nothing to remember by heart. Okay, sounds good. So now we have filled it. Now P4. When did P4 finish? P4 finished at 3 seconds. Now by the time I've reached 3 seconds, is there any other process now that is in the queue? So this process completed. At 3 seconds, okay, I have process 7, which came into the ready queue exactly at 3 seconds. Right? Which means I can schedule this. There is only one process that is competing for the CPU. Other processes haven't even arrived. So I'll schedule P7 now. Okay. At what time was P7 scheduled? P7 was scheduled at 3 seconds. Okay. Now how much time did it take? Its burst time is 2, which means it requires 2 seconds of CPU time. So which means it will complete at 5 seconds. What is the turnaround time? Completion time minus arrival time. So 2 seconds. What is the wait time? Wait time is turnaround time minus burst time. 0 seconds of wait time. What time did it complete? It completed at 5 seconds. Okay, its completion time is 5 seconds. All of this is good now. Let's change the colors a little. So this is also completed. Now I've reached 5 seconds. At the time of 5 seconds, what all processes are there in the queue now? I have process 5 and process 2 also, which just arrived. Because its arrival time is 5 seconds. This arrival time is 4. Right? So I have these two processes. Now between these two processes, which one does first come first serve choose? Whichever has the lower arrival time. So it chooses P5 now. Right? It chooses P5. At what time was P5 scheduled? P5 was scheduled at 5 seconds. And when would it complete? 3 plus 5 is 8 seconds it would complete. What is the turnaround time? Completion time minus arrival time. So 4 seconds. What is the wait time? Turnaround time minus burst time, which is equal to 1 second. Very good. At what time did it complete? It completed at 8 seconds. Okay. So 5 is also completed now. We've finished P5 also. Now at 8 seconds, which all processes are there in my queue? Look at this. This process came into the queue at 6 seconds. This process came into the queue at 7 seconds. This process came into the queue at 8 seconds. Now, which means which all processes do I have? 1, 2, 3, 6. Of all these 4 numbers, which is the smallest? P2 is the smallest. Right? And because FCFS picks whichever has the smallest or the lowest arrival time, it picks that. So I'll schedule P2 now. Right? What is the schedule time of P2? P2 got scheduled at 8 seconds. When does it complete? What is the sum of these two? At 13 seconds it will complete. What is the turnaround time? Completion time minus arrival time. Right? Completion time minus arrival time is your turnaround time. What is the wait time? Turnaround time minus batch time. Right? So 8 minus 5. Right? So this is equal to 3. Very good. Or burst time, not batch time, burst time. I'm sorry. BT is burst time, right? So 8 minus 5 is 3. So this is cool. So what time did P2 complete? P2 completed, but P2 completed at 13 seconds. Very good. Okay. Now comes, so at 13 seconds, again, all the processes are there in the queue. Now what all I'm left with? I'm left with 1, 3 and 6. Of all these 3, which is the oldest process or which process has the lowest arrival time? 6. Right? So we'll schedule P6 now. Okay. So we'll schedule P6 now. So at what time did P6 get scheduled? At 13 seconds. Its burst time is 1. So it will complete at 14. What is its turnaround time? 14 minus 6. 8 is its turnaround time. What is its wait time? 8 minus 1, it waited for 7 seconds in total. Okay, so at what time did it complete? At 14 seconds, P6 completed. Cool. So P6 is also over. Now what am I left with? I'm left with 1 and 3. Which of them came first? P3 came first. Right? So we'll schedule P3 now. Okay, at what time did P3 get scheduled? P3 got scheduled at 14, right? Yeah, P3 got scheduled at 14. What time would it complete? Because the burst time is 2, it will complete at 16. What is its turnaround time? Completion time minus arrival time. So 16 minus 7 is 9. What is its wait time? Turnaround time minus burst time. It waited for 7 seconds. Very simple. So this is also over. Now I'm only left with this. Right. So when did P3 complete? Remember, P3 completed at 16. Right. P3 completed at 16. Now I'm left with only P1. P1 gets scheduled at 16. Right. When does it complete? 20. Because 4 plus 16 is 20. What is its turnaround time? Completion time minus arrival time. What is its wait time? Turnaround time minus burst time. That's it. Okay. So when did it complete? Completed at 20 seconds. Now the question was, what was the original question? What is the schedule length? What is the definition of schedule length? Schedule length is the total time it took from the time we started executing these processes to the time we finished all of them. Again, remember, many people make the mistake and say that the schedule time is 20. It is not 20 because we started executing the processes only at 2 seconds. Right? Before 2 seconds, we didn't execute anything because none of these processes even existed in the ready queue. Right? So if you have a Gantt chart like this, you can compute the schedule length as whatever is the last number here and whatever is the first number here. Right? The total schedule length here is 18. Okay, that's one way of looking at it. You can also compute schedule length by taking the maximum of, see, what is the definition of schedule length? It is the maximum of completion times minus minimum of arrival times. This is another way of looking at it. We discussed this in the past, in the previous video. What is the maximum of complete times? Maximum of complete times is 20. What is the minimum of arrival times? Minimum of arrival times is 2, which is also equal to 18. So you can compute the schedule length either using this formula or using the Gantt chart itself. Right? Very simple. Again, FCFS is a very, very simple algorithm. It's probably the simplest scheduling algorithm. We'll look at more complex, more real world scheduling algorithms as we progress one by one. Okay, so I hope with this, you got a sense of how to even think about, oh, there is one more question. So let's look at one more example, right? FCFS itself. FCFS. Right? Now this time, instead of trying to fill this whole table, let's directly draw the Gantt chart. Okay, look at this. So what are the arrival times now? 4, 10, 15, 20, 28, which means up to 4, I don't have any process. Look at this, up to 4, I don't have any process that is there, right? I'm simply sitting idle. So what happens? Up to 4, I'm sitting idle. Okay, I don't have any process that came in. Okay, at 4, I got process 1. Process 1 took 2 seconds to complete, right? So which means process 1 will complete at 6 seconds, right? At 6 seconds, are there any other processes here? So this is completed at 6 seconds. No other process is there up to 10 seconds, which means from 6 seconds to 10 seconds again. Look at this, from 6 seconds to 10 seconds, I'm still sitting idle. Okay, I'm still sitting idle. I've not yet finished. No other process arrived. Now at 10 seconds, P2 arrives. Okay, at 10 seconds, P2 arrives. Now P2 is the only process that is competing for it. So let's place P2 here. At what time will P2 finish? P2 needs 1 second of burst time. So it will finish at 11. At 11, is there any process? No, there is nothing. So this is completed. Up to 15, there is no other process. So which means till 15, the CPU will be idle. CPU is literally sitting idle here at this point of time. Right? Very simple here. The CPU is simply sitting idle here. At 15, you get process 3. Right? At 15, you get process 3. And process 3 requires 2 seconds, which means it will execute up to 17 seconds. So this is completed. At 17 seconds, P4 has not yet arrived, which means between 17 seconds and 20 seconds, the processor or the CPU is again empty. It's sitting idle. So all these are idle times. All these dash times, this time, all these are idle times. At 20, P4 comes into existence. P4 comes into my ready queue, right? So I'll schedule P4 now. So what P4 requires 3 seconds. So it will finish at 23 seconds. And again, once it finishes at 23 seconds, I still don't have any other process up to 28 seconds. So up to 28 seconds, I'm going to sit idle. At 28 seconds, I'm going to get my P5, right? And P5 will run for 8 more seconds, which means 28 plus 8 is 36. Now the question here is, what is the schedule length? So again, please don't make this mistake. Schedule length is, so some people remove all these hashed, remove this, remove this, remove this, remove this, and remove this, and they compute the schedule length. That's incorrect. Okay, that's why I've taken this example specifically. The schedule length here is the time at which the first process started. Look at this. The very first process here started at 4 seconds. So 4. When was the last process finish? The last process finished at 36. So which means what is the minimum arrival time? Minimum arrival time is 4. What is the maximum completion time? Maximum completion time is 36. So 36 minus 4, which is equal to 32, is the schedule length. Okay, very, very important. This is a very common mistake that I've seen folks make, which is they take 36 minus 4, which is 32, and then they subtract this, they subtract this, they subtract this, and they subtract this, which is incorrect. Okay, because what is the definition of schedule length? Schedule length's definition is maximum completion time minus minimum arrival time. The maximum completion time here is 36. The minimum arrival time is 4. Look at this. You can actually draw the Gantt chart without needing to draw all of this table. By just having these first 3 columns which are given to us, without filling this, using Gantt chart, you can compute everything that you want. Very, very easily, right? So this is a first very simple algorithm called as first come, first serve. We'll learn of more algorithms little later.